Hi, it's Kristen Atchison, and we're talking about non-experimental, quasi-experimental, and experimental methods. And we're kind of just going to distinguish between the three. We're not going to go into a lot of detail about any. The majority of our course as a whole will focus on experimental methods. But I wanted to kind of introduce this quasi-experimental method that's kind of in between the non-experimental methods you learned in 3510 and the experimental methods that we're going to learn about in 3530. So quasi-experimental is this middle ground. Okay, quasi means resembling an experiment. So that's what we're going to talk about. First, let's do some review from 3510. So variables. What are variables? A variable is anything that varies, okay? So if it's anything that changes, whether you are changing it as the researcher or whether it is just changing naturally, that is a variable. We can have again, it has to have at least two levels. It can have more than two levels, but it at least has to be the difference between two different things. If it only has one level, it's not a variable. It's a constant. It's not something that's varying. It's something that's staying constant or the same. So again, a variable is anything that has at least two levels, and that has change. The different kinds of them, we have measured variables. So if you're measuring heights of your participants and looking at a correlational study, that would be a measured variable. It's something that varies, it's something that varies naturally, and it's something that you are measuring. That can also include things like a subject variable, something about the subject, male or female. Two levels. It is, again, a subject variable because it has two levels, but it's something about the subject. It's something inherent to the subject themselves. It's not something that we ourselves can manipulate. It's just something that we can measure. Another example would be kind of diagnoses, things like that, where somebody is maybe on the autism spectrum, something like that. That would be a measured subject variable. The other kind that we're going to talk about, and we're going to spend the most time in 3530 talking about this kind of variable, is a manipulated variable. This is something that we as researchers are manipulating. So again, we're doing something to maybe to create the different levels of it. So we have a control condition or an experimental condition. One group gets one thing, one group doesn't. We have that vary because we have the two different levels, but we are manipulating it. We are creating that difference. We are creating that variability between them, as opposed to that being more naturally occurring and with a measured variable. So again, measured variables are observed and recorded. They already exist. We're not doing anything to them. They're already there. Where manipulated variables are controlled. These are the ones that we're interacting with. This is the one that we are changing. We're controlling it in some way or another. Some variables can only be measured, not manipulated. So height is an example of one. I can't manipulate how tall you are. You're the height that you are. I can't manipulate your gender. You're the gender that you are. I can't manipulate a diagnosis in a population. People have the diagnoses that they have. Those are things that are measured variables. There's no way for us to manipulate those. Some variables can either be measured or manipulated. There's things that you can kind of manipulate, and then there's things that can be measured too. So if we were looking at, and we will do a really bad experiment later about thirst, you can just measure thirst. So we can kind of see how thirsty you are and just measure that. But we could also manipulate your thirst. We could make you thirstier by giving you something really salty, or we could make you less thirsty by giving you something to drink. So thirst is something that we could either measure, just kind of report how thirsty you are, or do some sort of a more physiological measure of that, or it's something that we can manipulate by either making you thirstier by drying you out, giving you salt, giving you some sort of medication that creates dry mouth, something like that, or by making you less thirsty, by giving you something to drink, by making sure you're properly hydrated. So again, that could be measured or manipulated. So we're going to kind of talk about these things in terms of a continuum. And again, and I'll do these several times. So this is our continuum of control. And it's just this, again, this big line where we have on one side of it, we have little or no control. So we have little or no control over the variables. And on the other end of the spectrum, we have a high degree of control over the variables. So we have, this is where we're having our manipulations are done on this high degree of control. And so I want to kind of think about these three kinds of designs, experimental, non-experimental, and quasi-experimental, on how they are based on control. Experimental is the most highly controlled of the three designs. This is where we are manipulating things. And as you'll see, the only thing that we're manipulating is the variable that we're interested in manipulating. So that independent variable. The other variable that we're looking at is our dependent variable, and we'll measure that. But every other variable we're going to do something to control it. Either that or make it a constant that it doesn't vary at all. So we'll do some sort of control measure in these experimental designs so that the only two variables that can vary are the two that we're interested in, that independent variable and that dependent variable. Whereas the designs you learned in 3530 are non-experimental designs. They're going to have little or no control. Maybe they just took a survey and measured several different things and looked at correlations. There's little or no control there. What they're doing is they're just measuring things, whether they're making just frequency claims. Again, these are ideas from 3510, or whether they're making association claims. That kind of depends on the individual kind of design in that non-experimental category. Whereas quasi-experiments are going to be more in the middle. They're going to be more towards experimental. We're making attempts at this control. We're making attempts to control variables. But there's something about these quasi-experimental designs that we can't control. Maybe it is a subject variable. Maybe we're looking at the difference in gender on these things that we're measuring. Maybe there's something that we can't necessarily control. And that's where we're going to be in these quasi-experimental designs. We're doing everything we can to make sure that we're manipulating and measuring things and really trying to look at cause and effect. But there's something that we can't control. Usually it's a subject variable, and that puts us in this quasi-experimental design. Rarely are you going to have them kind of down here. Again, most of the time they're going to be just outside of experimental designs. Validity. What is it? If something has validity, it's valid. Another word for valid is true. So if something has validity, we're talking about how true is something. Here at Research Methods, we like to make big words and talk about things a little bit differently, but really we're just talking about how true is something. So in research methods, we talk about several different kinds. And in experimental research methods specifically, we're really interested in, and what we're putting the most energy into, is our internal validity. Again, internal validity just means, is it true inside the research design? So again, internal validity. So are the explanations that we're making, are they true? Are these explanations between these cause and effects between our independent variable and our dependent variable, are they true? Or is there something else that we didn't control for? So we're going to be mostly concerned with this internal validity. Is it true inside the research study, inside the experiment? And one of the ways we mostly do this is by controlling external variables. So anything other variable outside our independent variable that we're manipulating and our dependent variable that we're measuring is an extraneous variable. And again, we need to figure out some way to control those. We either control them through various control techniques, or we make them a constant and take them out of that variable condition as a whole. So if something you could do is, if you're doing a study into your experiment in two different rooms, or even in the same room, something that could vary would be temperature. So you can make sure that it's the same temperature in the room. That's an example of holding something constant so that it's the same. If you don't control these extraneous variables, then you have design confounds. And a design confound is saying that there's something wrong with your study. There's something wrong with the internal validity. We have another explanation about what could be causing change on this dependent variable. And again, we're going to spend a lot of time talking about these things. This is just really kind of the gloss over on internal validity. We have whole parts of chapters dedicated to it, so we'll spend more time here. Another thing that we have with studies that have really high internal validity is random assignment. This means that everybody has an equal shot of being in either the control or the experiment group, being in the various levels of the independent variable. And again, this is going to be really, really important, and we'll spend a lot more time talking about why. The more controls we have in a study, the more internal validity a study has. And again, we'll spend a lot of time talking about this, but experiments are the ones that have the most internal validity, whereas non-experimental designs are going to have the least amount of internal validity. So again, internal validity is talking about the explanations of cause and effect. And are we able to say that our independent variable is the cause on the change on our dependent variable, the effect? Or is there other things going on? So our internal validity is, are we able to say that our study was valid inside and that our independent variable caused the change on our dependent variable? This is a really, really helpful table from your textbook. It's table 3.2, and it talks about the different kinds of claims that research makes. Frequency and association claims are the ones that you focused on in 35.10. And again, a frequency claim is measuring something. It's measuring how many people think regifting is acceptable. It's measuring how many women use vocal fry sounds. Whereas association claims are kind of taking two measured variables, sometimes more than two measured variables, and creating associations between them. This is where your correlations and those sorts of things are coming in. So smart jocks, fit kids do better at math and reading. Bedroom TVs may boost risk of fat and disease. So it's again, they're measuring the fitness of the children, and they're measuring their math and reading performance, and they're creating associations between these. They're measuring who has a TV in their room, and they're measuring the body fat and risk for disease, and they're making associations between these. Again, all we've been dealing with in these frequency claims and these association claims is measurement. Causal claims is when we're talking about cause and effect. And the only way that we can talk about cause and effect is through an experiment, and a true experiment at that. And this is where we're saying that our independent variable caused change on our dependent variable. So texting is blamed for rising pedestrian injuries, would be a causal claim. So you would have to actually ask a group of people to text and add another group of people to not text, and see if their accidents go up in a driving simulation. Things like that. That would be cause and effect. An example would be the music lessons enhance IQ. So you have a group of students who are assigned through random assignment to participate in music lessons, and you have a group of students who are assigned maybe to participate in another kind of lesson, or no lessons at all. And then you measure their IQs both before and after these lessons and see if IQ scores change. Did the music lessons increase IQ? Frequency claims describe a particular rate or degree of a single variable. So again, this is where we're measuring something. We're just saying how many people do this, how many people believe this, how many people think this. We're just measuring things. Frequency claims are involving just one measured variable. Again, this is all review from 3510. Association claims, these are talking about multiple measured variables, and are making an association or trying to gauge the relationship between these variables. So these need to involve at least 2 measured variables. You could have more than 2, but you have to have at least 2 for there to be an association or a relationship with these. Variables that are associated are those variables that are correlated. So if you have a high correlation, you have a high, they're going to be making association claims based on those high correlations. We use these associations to make predictions. That's where regression and all of that fun stuff came into play. Again, these are useful because they can make predictions. If these 2 things are in relationship and we have that nice line, we can make predictions on, well, if you have this, where you'll be on this other variable as well. So we can make these kinds of things. The stronger the association, the stronger the correlation, the easier it is to make that prediction. And this can be done with both positive associations, which would be positive correlations, and negative associations, which would be negative correlations. But when you have no correlation or no association, you can't make these. Here's an even more helpful table from your textbook. So I would recommend putting a flag in your textbook here and referring back to this throughout the semester. It'll be very, very helpful for you when you're looking for articles and trying to judge what kind of claims studies are making. So again, it talks about what kinds of verbs, how they write about association claims versus how they write about causal claims. So again, use this to help you find articles when you're looking for an experimental or a quasi-experimental design. If they're using the association verbs, they're making association claims, don't use that study. You need to be looking for studies that are making these causal claims, that are making these, using these causal verbs, that are saying that their independent variable caused change on their dependent variable. So here's a new continuum. This one's about types of claims. Again, experimental designs are where we make causal claims. It is the only way that we can make causal claims, and that's why it's the gold standard of research, not just for psychology, but other areas of science as well. So again, experimental designs are our kind of gold standard. It's the only way that we can say that one variable is causing change in the other variable. Association and frequency claims are going to be non-experimental designs. Again, we're only dealing with measured variables there. Things are only being measured, not manipulated, so we're not going to be able to make those claims. Whereas quasi-experimental designs, as you guessed, are back in the middle. They're going to, again, be closer to these causal claims because they're going to have manipulated something, chances are, or are using something towards an independent variable. But they have some sort of subject variable, some sort of something that has put them just outside of the control needed for a true experiment. So they're going to be almost making causal claims, but not quite. Again, these are still dealing with manipulated variables in these quasi-experimental designs. Again, rarely are you going to see something down here closer to an association frequency. If you're down here, this is not going to be a true quasi-experimental design. So characteristics of the non-experimental, we've had little or no attempt to control the confounds or any threats to internal validity. We're just measuring stuff and seeing how they're related, or just measuring them to see how much of them there is. Again, this is what you were learning in 3510. So 3510 was all about non-experimental designs. Again, these lack control and manipulated variables. The researchers aren't manipulating anything. We only see manipulation in quasi-experiments or true experiments. Because there's no manipulation, we don't have a lot of internal validity. Again, these are those frequency and association claims. Here's an example from the literature that kind of shows us what this looks like. When you're looking up research, the best thing to do is start with the abstract and look for these association verbs. Look for the frequency verbs. Look for the causal verbs. If you're looking for a paper for that's quasi-experimental or experimental, you're going to be looking for those causal verbs. So here it talks about in the study of naturally occurring family conversations, parents were 3 times more likely to explain science to boys than to girls while using this exhibit. So they're talking about frequency here. They're saying more likely to, they've measured how many times that they used these explanatory science terms and well in this situation. And they measured it, and they found that boys got more science talk than girls did. So these are non-experimental designs where we're just measuring things. We're not looking at any kind of manipulated variables. We're in true experimental designs, and again, this is just kind of an overview. We're going to spend the rest of the semester when we talk about research methods talking about experimental designs. So for true experimental research, an experiment must include an independent variable. These are, again, those manipulated variables. We're doing something with this. It also must include a dependent variable. Our dependent variable is our measured variable. Our independent variable is going to be our cause, and our dependent variable is going to be our effect. Anything else other than the two variables that we're interested in are extraneous variables and need to be controlled in some sort of way. The other thing that we have in experimental research that makes it a true experiment is random assignment. If we don't have random assignment, but we have everything else, we're probably in that quasi-experimental design. So if we're measuring two different age groups, that's going to, and looking at them on different ways, chances are that's going to be a quasi-experimental design because I can't assign you to be a certain age. You just are the age that you are. Characteristics of these true experiments, again, include a manipulated independent variable. Our independent variable isn't an independent variable if it's not manipulated. So again, to look in, one of the easiest ways to see if you have a true experiment is, did they manipulate a variable? Did they change something themselves? Did they randomly assign people to one group or another? And did they change what was being received between those two groups? The most simple form of this is a treatment condition and a control condition, or experimental condition and a control condition. One group got something, one group didn't. Again, these really have a high degree of control, and this includes things like random assignment to conditions. So when we do our little fake experiments in class, we'll have random assignment. I have a plastic bag, and we put all your names in it, and we randomly assign you to different conditions. What this gives us is an unambiguous outcome regarding whether the independent variable caused change on the dependent variable. If the dependent variable changed, we can say it was the independent variable because nothing else was changing except the independent variable. We hold everything else constant, all those other extraneous variables, or we controlled them in some other way. So the only thing that could cause this change on the dependent variable is our manipulation of the independent variable. What this is called is internal validity. So again, we have internal validity when it's clear that our manipulation of the independent variable is what caused change to the dependent variable. So again, that's really what we're looking for in these true experiments. If you have an experiment that has kind of all of this, but we're missing that random assignment, or there's two different things that they're looking at, we have an experiment, but then we take that experiment and we look at two different age groups, then we're kind of outside that true experiment. We have something that's not randomly assigned, and so we'd be in this quasi-experimental design. So here's an example of an experiment abstract from the literature. This is looking at child-directed speech, so again, how we speak to children. And the easiest way to tell that this is an experiment is they say, in two experiments, they call them experiments. Because experiment is our gold standard, researchers are really quick to tell you that they did experiments. They want to tell you that they did experiments because they want to say, hey, this is a causal claim. We did it. We found that this is causing change in this. Here they're looking at whether they gave names alone, an object name by itself, or if they gave it in a sentence. So that's the independent variable. They give them a word, and they either give them just the word, or they give them the word in a sentence. And what they measured, the dependent measure was how long it took them to figure this word out. Okay, and they did this with 18-month-olds. So they took this one group of kids and they randomly assigned them to these two different conditions, whether they got it in isolation or whether they got it in a sentence form. So we have two different levels of that one independent variable. And we measured our dependent variable, how long it took them to interpret this. And so they found that they were slower to interpret the target in isolation than when they were given that same word in a sentence, telling us that that sentence frame actually helps us understand words better. They were better able to understand words when we gave them to them in a sentence than when they got them by themselves. And again, they're making these cause and effect kinds of statements. They're saying they were slower to interpret the target. This is what happened. They didn't do as well, suggesting that sentence frame facilitated word recognition. It made them better. It facilitated it. This is what caused the change in word recognition. So again, when you're looking in the literature, look for your independent variable, what they manipulated, look for a dependent variable, what they measured, and look for those cause and effect kind of statements that they're talking about. Again, make sure you're looking for random assignment as well. Quasi-experiments, again, I've already mentioned this, quasi means resembling. So we're doing everything that we can to be an experiment, but we're just a little bit outside of that. So these are a really important alternative to these true experiments when we can't do a true experiment. So again, there's things that we can't assign you to. We can't assign a group of people to be schizophrenic and a group of people to not be schizophrenic. You are schizophrenic or you're not schizophrenic. We can't assign those kinds of things. And so they're really important for us to kind of start to look at these things in more causal ways without being able to make true cause and effect statements. Again, they lack the same degree of control, high degree of control that we have in a true experiment. And because of this, this creates alternative explanations. So we're not able to say that X is definitely causing or X is causing Y. We can say X is likely causing Y, X may be contributing to Y, but something else is going on that keeps us from being able to say that A is causing B or X is causing Y. So again, they lack this same high degree of internal validity. When you see alternative explanations, you know you have low internal validity. When you see no alternative explanations, you have high internal validity. So what we have to do then is we have to look somewhere else, do another study, look at it from a different angle to get additional evidence to eliminate those alternative explanations. So a lot of times you'll see multiple studies done where they're like, okay, well, we did it this way and we found it. And so then we did it this way. We changed this a little bit and did it too to see if we're still finding the same thing. What they're doing is saying, okay, well, this was a threat to internal validity, so we're going to test this threat. We're going to test this alternative explanation and see if we find something else. Again, these quasi-experimental designs are usually dealing with either intact groups or subject variables. So we're using a pre-existing group, and again, these are typically based on subject variables to automatically assign participants to groups. So in that experiment on child-directed speech and word recognition, her experiment would have become a quasi-experiment if she also looked at gender, how gender influence this. Do boys do it differently than girls do? Were their reaction times different? Because you can't randomly assign infants to be male or female. They just are male or female. So again, we couldn't control that. We have a subject variable at play. So she was also looking at that. She still manipulated the word frame. She still measured how long it took them to interpret it. But she also looked at the subject variable of gender. Then we'd be a quasi-experimental design. Another example would be if she looked at both 18 months old and 24-month-old. She looked at two different age groups to see if the same thing was happening at both groups, if this was involved. And again, this would make it a quasi-experimental design because she did something outside of her control. You can't assign kids to be 18 months or 24 months. They just are 18 months or 24 months. So true experiments cannot have intact groups or subject variables if you're a true experiment. And that's where, again, why quasi-experiments are important because sometimes you need to look at these things, especially in developmental work. We look at ages and how how different ages of development do different things. We look at genders. We look at these other variables that are subject variables, different school environments, different family environments. We look at these subject variables to see how they influence development. And so we need to have quasi-experiments because you can't always assign people to some of these really important parts of life and of psychology. And the reason, again, that we can't have these intact groups is because, again, it's giving us an alternative explanation to why there was a change in that dependent variable. And it's not that the independent variable caused change on the dependent variable. We have some other explanation as why. It could be that it's just that the kids are older. It has nothing to do with the sentence frame. They're just better. So again, it gives an alternative explanation. So studies that involve intact groups or subject variables are going to either be non-experimental or quasi-experimental. And again, it depends on what they're doing with those intact groups, what they're doing with those subject variables, to whether it is a manipulated. If there's manipulation, then we're going to be more quasi-experiment. If we're just measuring, it's going to be more non-experimental. So again, look at whether they're manipulating variables to see if it's quasi-experimental. Looked at their level of control, the kinds of claims that they are making to determine if they're making is a quasi-experimental design or a non-experimental design. And again, these phrenolid examples that I just gave you above would be examples of quasi-experimental design. It's something that's taken that experiment and it's put it just outside of true experiment. We're in these quasi-experimental designs. Here's an example of quasi-experimental designs in the literature. Again, most of my articles are about infants because that's what's on my computer, so those are the easy ones to find, so bear with me. Here they're looking at discrimination of musical excerpts, and they're doing it at 4 different ages. They're doing it at 3, 5, 7, and 9 months of age. And so what they're doing here is by looking at these 4 different ages, that's a subject variable. Again, we can't assign these people to be 3, 5, 7, or 9 months old, they just are. So these are subject variables, and we can't control for that. We don't have random assignment, so this is going to be a quasi-experimental design. So distinguishing where on the continuum, again, these non-experimental designs are going to be measured, not manipulated. So we're only measuring things in non-experimental designs. They're either just looking at the relationship between 2 or more variables, or they're just measuring how often something's happening. Again, these are those frequency and association claims. Where quasi-experiments, we're doing everything that we can to be this highly controlled experiment, but something we can't control. It could be a subject variable, it could be something else that's put us just outside of this. We're still manipulating something. We're still measuring something. We're still looking at this cause and effect relationship between the independent variable and the dependent variable, but there's something else that we can't control, and so this has made it a quasi-experimental design. So again, attempts have been made at manipulation. There's an independent variable. Controls to improve internal validity. We're doing things to account for these alternative explanations. Maybe they have one independent variable that's manipulated, like the example of the word frame. So the word frames is manipulated, and one that's a subject variable. If she had looked at it at 18 months and 24 months, that would be an example where we have both things going on. And experiments are usually the easiest to distinguish because the independent variable and the dependent variable are very clear. This is what we manipulated. This is what we measured. So we have a manipulated independent variable. Again, they have this really high degree of control, and the thing that makes them most easy to recognize is usually the researchers are going to tell you, yes, this is an experiment, because there's so much weight behind that word in the research community. They're telling us right up front that all of these things are true, and so they're going to often mention it as an experiment in the paper. It may not be in the abstract. You may have to kind of flip through, but they're going to be mentioning that their study is an experiment. And so our final continuum here, we have where these things are in terms of control. Again, experimental designs have the highest degree of control, and they are our gold standard. Where non-experimental designs are those designs from 3510, and we're going to not really focus on those. You can use non-experimental designs for your synthesis paper, but again, for your ERS and for one of your articles for your synthesis needs to either be this quasi-experimental design or a experimental. So we need to have either quasi or experimental designs. Non-experimental designs are really not appropriate for this class. Again, the reason that we do that is because this class is teaching experimental design. So it's one of the things that's really important to us is that you're able to recognize an experimental design. So now that we've introduced these three things, there's a participation question that has several abstracts where you can go in and determine which of the three those abstracts are. Another really helpful thing to do would be to go through and look at research articles and see if you can determine what is what. I would really like it if you could find an article, and I'll create a Dropbox that you can upload it to. So look for an experimental article so that you can show me that you can recognize it. I don't care what the article is about. I don't care if it's not anything you're interested in using for your papers. Just look for a psych article that's experimental and upload it into that Dropbox that will be in the folder. Thanks so much, and see you in class.